You are about to step back in time to a warm August morning in 1945. Imagine yourself in a bustling Japanese city, Hiroshima. An elderly vendor might be arranging fresh fish at a market stall. A streetcar clatters by, carrying office workers in their suits. School children in uniform laugh and chat as they skip along the sidewalks. Housewives are airing bedding on their balconies under the clear sky. It is, in many ways, an ordinary warm day in a city at war, yet somehow untouched by the war's destruction so far. The streets are alive, with people heading to work, children on their way to school, and shopkeepers opening for the day. At this moment, Hiroshima and another city, Nagasaki, are vital centers for Japan's efforts in World War II. Factories in these cities churn out supplies for the military, and even students help in factories as part of the war effort. Life carries on under the summer sun, and although the country is weary from years of war, surrender is not yet in sight. But far away, an ominous new weapon is being prepared in secret. The United States has been racing to develop an atomic bomb under the code name Manhattan Project. By July 1945, a test explosion, codenamed Trinity, has already proven that this new weapon works, unleashing a power unlike anything seen before. Witnesses of that test stood awestruck. One of the lead scientists, Dr. J. Robert Oppenheimer, later recalled a line from scripture, "Now I am become death, the destroyer of worlds." Now, in the early hours of the 6th of August 1945, a specially outfitted American bomber plane called the Enola Gay takes off from a remote Pacific island. Its mission is to drop the first atomic bomb used in war, and the target is the city of Hiroshima. You can picture the silver B-29 bomber high above, droning toward Hiroshima that morning. At 8:15 a.m., the bomb is released from the aircraft, beginning its descent toward the city below. The crew of the Enola Gay immediately veers away sharply to escape the coming shockwave. One of the crew members later described seeing a huge cloud rising and the city disappearing beneath it. Even at their distance, the shockwave struck the plane like a giant hand, causing it to lurch. They knew in that moment that their mission had unleashed something terrible. Only 43 seconds later, the bomb detonates in a blinding flash a few hundred meters above the heart of Hiroshima. This device, codenamed Little Boy, unleashes an explosive force of about 15,000 tons of TNT. For an instant, night turns to day as an intense white light floods the city. A fireball blossoms in the sky, reaching temperatures of around 4,000 degrees Celsius at ground zero, roughly 70% of the sun's surface heat. In that first moment, anything and anyone directly beneath the explosion is simply vaporized. If you were standing close to the blast, you would simply disappear in an instant. The heat is so intense that it bleaches surfaces. In places where human bodies or objects briefly shielded walls and sidewalks, dark silhouettes remain after everything else is burned bright. These eerie imprints are often called atomic shadows, outlines of people who were there one moment and gone the next. One famous example is the dark shadow of a person etched into the stone steps of a bank in Hiroshima, all that remained of someone who had been sitting there that morning. Within a radius of a few hundred meters from ground zero, nearly every living thing is obliterated in the blink of an eye. It's estimated that around 70,000 to 80,000 people die instantly in that first burst of heat and shock. In mere seconds, tens of thousands of lives are gone. Slightly farther out from the epicenter, the effects are different, but still horrific. People caught in the open are seared by the thermal radiation, skin chars and peels away in sheets, clothing bursts into flame or fuses to flesh. Survivors in this zone stumble about with deep burns covering their bodies, skin hanging loosely from their arms and backs. The pain is beyond anything you can imagine. Many describe feeling as if they themselves are on fire. Without effective medical help, these burn wounds often become fatally infected. Many who survive the initial blast succumb to their injuries in the following days and weeks. It is difficult to even picture these scenes without feeling uneasy. If you notice yourself tensing up, just remember that you are safe in this moment, far removed from that day. You are simply listening to the echoes of history, and you can let these images drift by if they become too intense. After the flash of heat, a split second later comes the blast wave. A wall of pressure and wind radiates outward at hundreds of kilometers per hour. Buildings are smashed to splinters. Windows shatter, sending shards of glass scything through the air. Trees snap like twigs. People are picked up and hurled by this sudden, immense force. Anyone near windows or fragile structures is lacerated or impaled by debris. Many are crushed as their homes and offices collapse on top of them in an instant. Others, inside sturdier buildings, are knocked to the ground as walls buckle and roofs cave in. The air pressure changes so violently that eardrums rupture. Some individuals suffer internal injuries from the sheer force impacting their bodies. In the span of moments, Hiroshima is transformed from a lively city into a landscape of rubble and flame. Fires spring up all across the ruins, casting an orange glow under the billowing columns of smoke. The air is filled with the smell of burning wood, paper, and much worse. A strange twilight falls over the city as the mushroom cloud towers overhead. Amid the crackling of flames, the only sounds are the anguished cries of the injured, calling for help or for water, voices weak and desperate. Water, please. That sound was the groaning of those trapped in the rubble. In just one morning, Hiroshima had become a scene of hell on Earth. Along with heat and blast, the atomic bomb releases a burst of invisible radiation. Those who were relatively far enough to survive the immediate flash and shock now face this silent menace. In the hours and days after the explosion, people who looked unharmed begin to fall ill. They suffer from intense nausea, vomiting, and fever. Some bleed from their gums or under their skin. Hair falls out in clumps. These are the symptoms of acute radiation sickness, a condition no one at that time fully understood. Cells deep inside their bodies have been damaged by penetrating gamma rays and neutrons. Many of these victims pass away within days to weeks, despite showing no visible injuries at first. In the years to come, those who survived both the blast and the sickness carry a higher risk of cancers, particularly leukemia and cancers of the thyroid and other organs, due to the radiation that penetrated their bodies. To truly understand what this felt like on the ground, consider the story of one survivor, a young girl named Reiko Yamada. Reiko was 11 years old that summer morning in Hiroshima. She was at school, out in the schoolyard under the bright blue sky. She and her classmates were preparing for the day's activities, perhaps glancing occasionally at the sky as children do. At one point, Reiko heard a boy shout, "Look, a B-29. She looked up and saw a lone American bomber high in the sky, leaving a white vapor trail. For a brief moment, she found it beautiful against the clear blue backdrop. The next moment brought a blinding white flash. Reiko remembers everything going pure white, as if someone had detonated a giant camera flash right in front of her. She was knocked off her feet by the force of the blast and lost consciousness. When she came to, the world around her had changed into a nightmare. The school buildings and the surrounding neighborhood were flattened, fires were raging everywhere, and the sky had turned dark with thick black smoke. Reiko saw people stumbling through the wreckage, many of them horribly injured. She remembers seeing skin hanging off people's bodies, their clothes in tatters. Some were so badly burned that they did not look human. All around, people were crying out for water and help, but almost no one was in any condition to give aid in that moment of chaos. She also recalled that not long after the explosion, a strange, dark rain began to fall. The rain was thick, oily, and black with soot. It fell on the smoldering city and on the faces of the injured as they looked up in confusion. This black rain was full of radioactive ash from the bomb, and it clung to Reiko's skin and clothing. As the day wore on, the scale of the calamity became painfully clear. Thousands of injured people flooded into any available open space, moaning for help. Many of the wounded craved water desperately, their burns and shock leaving them almost maddened by thirst. People staggered toward the rivers, hoping to soothe their burns or find something to drink. So many succumbed there that the riverbanks became lined with bodies. In Reiko's recollection, the number of dead was overwhelming. Corpses lay in the streets, and because of the summer heat, the bodies of those who were not vaporized instantly had to be cremated immediately to prevent the spread of disease. Horrifically, they were piled in an empty swimming pool of the school, covered with wood and burned. Many of those people were never identified, as some were burned beyond recognition. No one was prepared for the aftermath of a nuclear explosion. At first, people in surrounding areas and elsewhere in Japan did not understand what had happened, only that an entire city was in ruins. In the hours and days that followed, doctors and rescue teams from other cities arrived in Hiroshima to help the survivors. They had no protective gear against radiation. In fact, they didn't even know such a hazard existed. Some of these first responders would later fall gravely ill themselves from exposure to the residual radiation lingering in the blast area. In those initial days, the priority was to put out fires, rescue anyone trapped under debris, and restore basic utilities like water to prevent further disaster. Many lives were saved by these efforts, but thousands could not be saved. People had to work quickly among the devastation. In Hiroshima, soldiers and volunteers even bulldozed collapsed buildings to create fire lanes to stop the fire from spreading further. They did all this, not knowing that invisible radiation was still penetrating the area, affecting many of the rescuers as well. Despite the unprecedented destruction in Hiroshima, the Japanese government did not immediately surrender. It is chilling to note that Nagasaki was not even the primary target that day. The bombers' first objective was the city of Kokura, but thick clouds obscured it, causing the mission to divert. Fatefully, Nagasaki became the alternate target. As a result, 3 days later, on the 9th of August 1945, a second atomic bomb was dropped on Japan, this time on the city of Nagasaki. Nagasaki on that August morning was a bustling shipbuilding center and port. People there had heard rumors of what happened in Hiroshima, but life went on with a mix of fear and routine. Fishermen were heading out to sea. Factory whistles blew to signal the start of work. Many were unaware that their city would soon suffer a similar fate. The weapon used was a different design, a plutonium bomb nicknamed Fat Man, with a force even greater than the Hiroshima bomb. Fat Man exploded over Nagasaki at 11:02 a.m., with the equivalent of about 21,000 tons of TNT. The hilly terrain of Nagasaki somewhat limited the radius of destruction compared to flat Hiroshima, but the bomb's effects were still calamitous. The fireball that engulfed Nagasaki was estimated at over 6,000 degrees Celsius, actually hotter than the surface of the Sunday. Anyone directly beneath that blast was vaporized in an instant, just as in Hiroshima, leaving only their outlines scorched on walls or steps. Around 70,000 people in Nagasaki were killed immediately by the explosion. In the days and weeks after, tens of thousands more perished from horrific burns and radiation sickness. It was observed that deaths from radiation exposure in Nagasaki peaked about 3 to 4 weeks after the bombing, as those who had absorbed high doses gradually succumbed. Once again, an entire cityscape was reduced to charred remains. A handful of individuals experienced both Hiroshima and Nagasaki. One such person, Tsutomu Yamaguchi, was in Hiroshima on business when the first bomb fell, and though injured, he made it home to Nagasaki, only to witness the second blast 3 days later. Astonishingly, he survived both and lived to old age, becoming a vocal advocate for disarmament. His story, and those of others like him, seem almost impossible, yet they underscore both the devastation of these weapons and the resilience of the human spirit. Those who survived the bombings, known in Japanese as hibakusha, meaning explosion-affected people, faced not only the challenge of rebuilding their lives and health, but also deep psychological scars. Many hibakusha were haunted by memories of the horrors they had witnessed. Some would have nightmares or flashbacks for decades to come. Survivors also had to cope with physical disabilities, chronic pain, and illness from their injuries and radiation exposure. Yet, as if these burdens were not enough, they often encountered social stigma as well. In the years after the war, there was widespread fear and misunderstanding about radiation. Some people in their communities believed the survivors might be contagious or that their children would be born with defects. As a result, many hibakusha were shunned, discriminated against in jobs, or faced difficulties finding spouses. The visible scars on their bodies and the long-term health issues they endured served as constant reminders of the bombing, both to themselves and others. Some hibakusha eventually found meaning by speaking about their experiences, hoping that their stories would prevent such horrors from happening again. They became living witnesses to the consequences of nuclear war, advocating for peace even while bearing their personal pain. To this day, in Hiroshima and Nagasaki, you can still find traces of that fateful morning. In some places, those haunting atomic shadows remain preserved as a stark reminder. Both cities have memorial parks and museums that display artifacts, from warped metal and melted glass to the charred shadows imprinted on stone steps. Every year, on the anniversaries of the bombings, citizens gather in Hiroshima and Nagasaki to float paper lanterns on the rivers and to pray for peace. One famous story is that of Sadako Sasaki, a young girl who survived the Hiroshima blast as a toddler but later developed leukemia. Believing in a legend that folding 1,000 paper cranes could grant a wish, she folded crane after crane in the hospital, wishing to get well and for a world without nuclear war. Sadako passed away before she could finish, but her classmates completed the task in her honor. Today, a statue of Sadako holding a golden crane stands in Hiroshima's Peace Memorial Park, and people from around the world send folded paper cranes there as symbols of hope and peace. These memorials exist to educate visitors about the horrors of nuclear warfare, emphasizing the importance of peace and disarmament. The resilience of the survivors and the memory of the victims stand as a silent plea for peace. The atomic bombings of Hiroshima and Nagasaki remain the first and only times nuclear weapons were used in war. These two events demonstrated to the world the almost unimaginable destructive power of this new technology. A single bomb could annihilate a city and inflict suffering on a scale never seen before. It underscored the sobering fact that in a nuclear conflict, there is no meaningful distinction between soldiers and civilians. Everyone and everything is devastated alike. In the wake of these tragedies, the world was forced to confront the terrifying potential of the nuclear age. Japan surrendered on the 15th of August 1945, bringing World War II to an end, but at an immense cost. In the following decades, international efforts arose to control and eventually eliminate nuclear weapons, driven by the hope that no city would ever again endure what Hiroshima and Nagasaki did. Treaties were signed to limit tests and proliferation of these arms. The number of nuclear warheads in the world, which once numbered in the tens of thousands, gradually declined after the Cold War. At the peak of the arms race, in the 1,980 seconds, there were over 60,000 nuclear warheads in existence. People around the planet, from statesmen to ordinary citizens, felt a moral duty to ensure that never again would weapons of such destructive capacity be used. Movements for peace and nuclear disarmament gained strength, driven by the vivid memories of Hiroshima and Nagasaki. Yet, even as people around the globe said never again, the reality is that nuclear weapons did not disappear. On the contrary, they multiplied. Remarkably, both Hiroshima and Nagasaki rose from the ashes in the years that followed. Today, they are vibrant, modern cities. Flowers bloom in parks that were once ground zero. Children laugh in schoolyards once turned to wasteland. The fact that life returned is a testament to hope and renewal, even after the darkest of times. In the aftermath of World War II, instead of dismantling these doomsday weapons, the world entered a nuclear arms race. The United States and the Soviet Union, later Russia, built thousands upon thousands of warheads during the Cold War. Even today, long after 1945, it's estimated that roughly 12,000 to 13,000 nuclear warheads still exist on Earth. Russia and the United States possess the vast majority of these. Together, they hold most of the world's nuclear arms. Russia roughly around 6,000, and the United States about 5,500 when counting warheads in all states of readiness. However, not all of those are deployed on missiles or bombers right now. Many warheads are kept in storage or retired. In practical terms, each of those two nations has around 1,600 strategic nuclear warheads actively mounted on missiles or ready to be launched from bases or submarines. Other countries also have nuclear weapons, but in far smaller numbers. The United Kingdom, France, and China are officially recognized nuclear powers as well, with China, for example, estimated to have on the order of a few hundred operational warheads. A few other nations possess nuclear arms too. These include countries like India, Pakistan, and likely Israel and North Korea, though their arsenals are much smaller, generally in the tens or low hundreds of warheads. The exact capabilities of modern nuclear weapons are shrouded in secrecy, but we do know that warheads today can be immensely powerful. The most potent warheads in current arsenals are on the order of roughly 1 to 2 megatons of TNT equivalent. That means a single warhead could equal the explosive power of 1 to 2 million tons of conventional explosives. To put that in perspective, Little Boy, which leveled Hiroshima, was 15 kilotons, or 0.015 megatons. So, the strongest warheads today might be about 100 times more powerful than the bombs that destroyed those cities in 1945. Furthermore, many nuclear missiles are designed to carry multiple warheads. A single intercontinental ballistic missile might deliver half a dozen or more nuclear warheads, each aimed at a different target, and each perhaps in the few hundred kiloton range. Technology has advanced so that one missile can unleash destruction on several cities at once. At one point, during the height of the Cold War, engineers even built a single bomb far more powerful than any in today's arsenals. This was the Soviet Tsar Bomba, detonated in a test in October 1961. The Tsar Bomba remains the most powerful explosive device ever created by humans. Its yield was approximately 50 to 60 megatons of TNT. That's over 3,000 times more powerful than the Hiroshima bomb. The Soviets nicknamed it Big Ivan. It was so enormous, weighing around 27 tons and over 8 meters long, that a special version of a bomber had to carry it, and even then it barely fit. When Tsar Bomba was dropped over a remote Arctic test site, it was equipped with a parachute to slow its descent, giving the delivery plane a chance to fly far enough away. Even so, the shockwave from the blast rocked the plane as it escaped. The bomb detonated at an altitude of about 4 kilometers above the ground, and the resulting explosion was astonishing. The mushroom cloud climbed roughly 60 kilometers into the sky, piercing the stratosphere. A flash of light from the detonation was visible over 600 kilometers away. People hundreds of kilometers from ground zero felt the ground tremble. Windows were reportedly shattered in distant villages. The shockwave even circled the Earth multiple times. Had there been any doubt about the sheer might of nuclear weapons, Tsar Bomba erased it. Interestingly, this bomb was deliberately designed to be cleaner than it could have been. Its engineers actually reduced its potential yield on purpose. Originally, it was conceived as a 100 megaton device, but they used some lead in its construction instead of uranium to tamp down the reaction and produce less radioactive fallout. Even at half yield, the blast was unfathomably large, but this modification helped ensure that the test did not flood the atmosphere with even more radiation. If they had gone for the full 100 megatons using a uranium tamper, not only would the explosion have been nearly twice as powerful, but the radioactive fallout would have been far more severe, possibly contaminating a massive area. Tsar Bomba was a technical marvel of destruction, but it had no practical military value beyond intimidation. It was simply too big and heavy to deliver against an enemy in any realistic scenario. Military strategists soon realized that loading a single plane with a single huge bomb was far less effective than arming multiple missiles with numerous smaller warheads. There are diminishing returns when it comes to extremely large explosions. Making a bomb 10 times more powerful doesn't make its destructive radius 10 times larger. After Tsar Bomba, no nation ever tested a bomb of that magnitude again. The world had seen the edge of the nuclear abyss and perhaps learned that bigger is not always better. Instead, nuclear arsenals shifted toward a focus on reliability, deployability, and strategic deterrence rather than sheer size. Today, nuclear weapons are viewed primarily as a deterrent, weapons never to be used, but kept as a grim insurance policy by the nations that have them. However, the danger has never fully gone away. From time to time, tensions rise, and world leaders remind each other and the world that these weapons exist. This kind of posturing is often referred to as nuclear saber rattling. In fact, in recent years, global tensions have increased to the point that the Bulletin of the Atomic Scientists, a group that monitors how close humanity is to self-destruction, set their famous doomsday clock to 90 seconds to midnight. Midnight symbolizes global catastrophe, and 90 seconds is the closest it has ever been. It's a reflection of how precarious things feel in the nuclear era. Even now, it is a stark image of how close we may stand to potential disaster. All it might take is a miscalculation or an act of aggression spiraling out of control, and those terrible weapons could be unleashed again. What would it actually mean if, say, the two largest nuclear powers, the United States and Russia, got into a full-scale nuclear war today? It's a grim scenario to imagine, but exploring it underscores why these weapons are never meant to be used. Both nations have developed new intercontinental ballistic missiles that can carry multiple warheads. Russia, for instance, has a missile known as the RS-28 Sarmat, nicknamed Satan II in the West, which can carry a payload of multiple nuclear warheads that can separate and strike different targets. The Sarmat is said to be able to deliver perhaps 10 or more warheads, each in the hundreds of kilotons range, and potentially deploy them on trajectories that are very hard to intercept. The United States, on its side, is developing a next-generation ICBM called the LGM-35, a Sentinel, to replace its aging Minuteman III missiles. This new missile will likewise be capable of carrying multiple warheads, such as the existing W-87 warhead, around 475 kilotons each. In an all-out nuclear exchange, each missile launched could rain destruction on several cities simultaneously. If a nuclear war were to begin, the outcome would be essentially unimaginable catastrophe. There would be no winners. Imagine one side launches a barrage of nuclear missiles. Within minutes, the other side's early warning systems detect it and respond in kind, a concept called mutually assured destruction. Submarine-based nuclear missiles from hidden subs in the oceans would also be launched, adding to the onslaught. High in the atmosphere, the first explosions might even be set off to create electromagnetic pulses that fry electronics and communications, blinding and confusing the enemy's response. Then warheads would rain down on cities and military targets. Command centers, missile silos, major infrastructure, all would be hit in the first wave. An intercontinental ballistic missile, once launched, takes only about 30 minutes or less to reach its target on the other side of the globe. Now imagine dozens or hundreds of such missiles in the air, each carrying multiple warheads. Some might be intercepted by missile defense systems, but with so many coming in, most would find their mark, especially since newer missiles can deploy unpredictable paths or hypersonic glide vehicles that are extremely difficult to shoot down. When those warheads detonate over their targets, each one forms a fireball nearly as hot as the sun's core. The centers of cities vanish in an instant. The blast waves tear outwards, pulverizing buildings into dust. Firestorms engulf everything that can burn. Those who are not killed outright in the target zones suffer severe burns and radiation exposure. The immediate devastation in each hit city would be almost total. Survivors close to ground zero would be very few, if any. Those on the outskirts might look on in horror at the sight of a mushroom cloud rising over what once was their city. And the nightmare wouldn't end with the initial explosions. The fires ignited by the bombings would produce immense pillars of smoke and soot, which would rise high into the upper atmosphere. If enough cities burn, this dark smoke could spread around the globe, blocking sunlight. Days would resemble extended dusk. There might be frosts and even snows in summertime as sunlight is dimmed for months or years. Some scientists predict that the ash from a full-scale nuclear war could lower global temperatures drastically, perhaps by several degrees Celsius, on the order of tens of degrees Fahrenheit, creating a so-called nuclear winter. Crops would wither in the fields under a crop's shrouded sun. The survivors of the war, those who managed to find shelter from the blasts, would then face starvation as food supplies run out. They would also face the silent killer of fallout, fine particles of radioactive material settling back to Earth, contaminating water and soil. Many of those who initially survived might not live much longer, succumbing to radiation sickness or hunger in the months after. Human civilization as we know it could collapse under such a scenario. The scale of loss and suffering is almost beyond comprehension. It's sobering to realize that while a nuclear war could kill hundreds of millions or even billions of people, it would not literally destroy the Earth itself as a planet. In other words, humanity could destroy itself, but the Earth would go on spinning. People sometimes ask, could a nuclear war actually blow up the planet or shatter it? The answer is no. Our nuclear arsenal, even at full force, is minuscule compared to the energy needed to destroy a planet. Earth has endured natural impacts and eruptions far, far more powerful than all of our bombs put together. For instance, the eruption of Krakatoa in 1883A volcano in Indonesia released an energy equivalent to about 200 megatons of TNT, roughly 4 times the yield of the biggest bomb ever built. The volcanic blast hurled 5 cubic miles of rock into the sky, and an inky black cloud of ash spread over the region, leaving the land in darkness. The ash thrown into the atmosphere dimmed the sun worldwide. The pressure wave from the blast was recorded circling the globe several times. It even lowered global temperatures by around 1 degree Fahrenheit for an entire year. Yet the Earth itself remained intact, of course. Going back much further, 66 million years ago, an asteroid struck the planet in what is now Mexico, the Chicxulub impact. When that asteroid slammed into Earth's surface at tremendous speed, it was as if a billion nuclear bombs detonated at once. The impact punched a transient hole in Earth's crust, nearly 150 kilometers wide, and sent billions of tons of rock and dust hurtling into the upper atmosphere and even into space. Everything near the impact site was instantly vaporized. Towering tsunamis radiated outward, and red-hot boulders rained down across the globe, igniting wildfires on continents far from the impact. The sky turned dark with debris and sulfur, plunging the world into a darkness that lasted for years. Plants withered without sunlight, and ecosystems collapsed. Ultimately, this single explosion, unleashed by nature, led to the extinction of about 3/4 of all species on Earth, including the dinosaurs. Estimates show that the kinetic energy yield of the Chicxulub asteroid's impact was around 72 million megatons, tens of millions of times more explosive power than the entire global nuclear arsenal. It caused devastating fires and a mass extinction, but even that colossal explosion did not break the Earth apart. Despite the huge impact and explosion nearly wiping out all life on the planet is still spinning and still full of life. Compared to that, even a doomsday scenario of all nuclear bombs on Earth detonated at once would be a faint whisper. Our weapons, as terrifying as they are to us, are trivial on a planetary scale. This is a humbling thought, that all our might still pales in comparison to natural forces. That said, while we cannot crack the planet, we could still render it uninhabitable for our own species. One hypothetical device often discussed in this context is something called a cobalt bomb, essentially a doomsday weapon designed to blanket the Earth in deadly radiation. The idea of a cobalt bomb was described by scientist Leo Szilard in 1950. He was not suggesting anyone build it, but rather warning how nuclear technology could be twisted toward a truly apocalyptic end. A cobalt bomb would be a hydrogen bomb encased in cobalt metal. When detonated, the intense neutron radiation from the explosion would transmute the cobalt into radioactive cobalt-60, a material that emits powerful gamma radiation. The explosion would vaporize this cobalt and loft it into the atmosphere, where it would spread far and wide before settling back to the ground as fallout. What makes cobalt-60 especially frightening is its persistence. It has a half-life of over 5 years. That means it would keep emitting deadly radiation for many years, slowly decaying but remaining lethal for the better part of a decade, and still dangerous even after that. Conceivably, a large cobalt bomb could saturate the entire planet with radiation, ensuring that nearly all humans and animals exposed would receive fatal doses. Even those who hid in shelters might have to remain underground for years. It's been said that perhaps only creatures with extreme radiation tolerance, maybe hardy insects or microscopic tardigrades, could survive a concerted cobalt bomb barrage. Thankfully, no cobalt bomb has ever been built or tested. It remains a theoretical worst-case concept. It serves as a reminder that while nuclear weapons can't blow up the Earth itself, they could potentially wipe out the people living on it. In effect, such a weapon is a doomsday device by design. Contemplating these scenarios is deeply unsettling. It reminds us why leaders and citizens around the world have worked hard to prevent nuclear war. We have come close to the brink a few times in the past, but so far, humanity has stepped back. The thought of devices like a cobalt bomb, or any use of nuclear weapons at all, is something we hope remains only in imaginations and never in reality. Truly, in a nuclear war, there would be no winners, only an unspeakable loss for all. That is the simple and sobering truth. Given how much effort and money continues to be spent on these arms, some estimates put global spending on nuclear arsenals at well over $100,000 every minute, one might wonder about the sheer destructive potential all these bombs represent. For a moment, let's engage in a thought experiment. What would happen if every nuclear warhead in the world were collected and detonated all at once in a single location? To make it interesting, imagine we choose the deepest part of Earth's oceans, the bottom of the Mariana Trench, nearly 11 kilometers below the sea surface. This is an extreme scenario that we hope would never occur, but it can shed light on the upper limits of destruction that human weapons could cause. First, consider the location. The Mariana Trench is located in the Pacific Ocean, about 200 kilometers east of the Mariana Islands. It's a vast, crescent-shaped gash in the seafloor, stretching over 1,500 miles, around 2,500 kilometers in length, and roughly 40 miles, 65 kilometers, wide in places. At its deepest point, known as Challenger Deep, it plunges roughly 36,000 feet down, about 11,000 meters. That is deeper than Mount Everest is tall. Down there, the pressure is crushing, more than 1,000 times the pressure at sea level. It's an environment of perpetual darkness and extreme cold, truly one of the most remote and hostile places on the planet. This trench exists because one tectonic plate, the vast Pacific Plate, is slowly sliding under or being subducted beneath the smaller Philippine Sea Plate, forming a deep trench and a zone of frequent, powerful earthquakes. Now, into this setting, we imagine bringing all of humanity's nuclear warheads. If all those warheads were detonated together in the depths of the ocean, the effect would defy easy comparison. The water would not contain the blast. Instead, it might actually amplify certain effects. The combined explosion, amounting to many thousands of megatons of TNT, would create an immense bubble of hot, high-pressure gas at the bottom of the trench. For an instant, that bubble would push against the crushing weight of the ocean above. But the bubble would expand with unbelievable force, displacing billions of tons of water. A massive cavity would form in the sea, and very likely it would punch through the overlying water all the way from the seafloor to the surface. In other words, a column of water and superheated steam would shoot upward, blasting out of the ocean. The shock could even disturb the Earth's crust at the site. The Mariana Trench's rocks, already stressed by tectonic forces, might fracture further. It's conceivable a portion of the seabed would be blown out, exposing glowing magma from the mantle below. Anyone watching from a safe distance would see the ocean surface bulge up in a great dome and then erupt into a towering plume of steam, water, and debris. The pressure wave in the water would trigger monstrous tsunamis. Walls of water, potentially hundreds of meters high near the blast, would propagate outward. Islands nearby, like some of the Mariana Islands or Guam, would be utterly inundated, scoured clean by the waves. The Pacific Rim, coasts from Asia to the Americas, would likely experience giant waves crashing ashore hours later, causing destruction along far-flung shorelines. The scale of the tsunamis could be like nothing witnessed in recorded history. It would be no less devastating than the Chicxulub asteroid impact itself, and most living creatures might die as a result. From tragic man-made errors to the unfathomable forces of nature, we see that explosions, no matter their origin, wield a fearsome power, unleashing cataclysmic consequences. They can trigger tsunamis, awaken dormant volcanoes, reshape global climate, and threaten to fracture our entire planet. To further grasp this, it helps to look at a few of history's massive explosions, both accidental and experimental, and then at the even greater blasts nature itself can produce. One famous non-nuclear explosion was the Texas City disaster of 1947. In the port of Texas City, Texas, a ship called the SS Grand Camp was loaded with about 2,300 tons of ammonium nitrate fertilizer, the same compound that, under certain conditions, can become a powerful explosive. A fire ignited in the ship's hold, and despite efforts to control it, the crew actually avoided using water, fearing it might ruin the cargo or worsen the situation. The heat built up until finally the entire load detonated. The blast was enormous. It was heard as far as 150 miles away. A towering reddish-orange mushroom cloud rose into the sky, climbing roughly 600 meters, about 2,000 feet. Two small airplanes flying nearby were caught in the explosion and destroyed. The harbor and surrounding industrial area were devastated. The nearby Monsanto chemical plant was engulfed in flames, and pieces of the ship were flung in all directions like fiery shrapnel, igniting more fires around the city. The explosion sent a shockwave that created a wave in the harbor, a mini tsunami that crashed into the docks. It flattened warehouses and homes along the shoreline, leaving around 2,000 people homeless in an instant. All told, hundreds of people lost their lives in that disaster. And shockingly, just a day later, a second ship, the SS High Flyer, which had been damaged and set ablaze by the first explosion, also exploded in the same port, compounding the tragedy. At the time, Texas City was considered one of the largest non-nuclear explosions ever to occur. In a flash, a bustling port city was reduced to ruin. It was as if a glimpse of the coming nuclear horrors appeared decades early. Yet, as devastating as it was, another accidental blast decades earlier had been even more destructive. That was the Halifax explosion of 1917. During World War I, the harbour of Halifax in Nova Scotia was a busy wartime port. On the morning of the 6th of December 1917, a French cargo ship named SS Mont Blanc was navigating into the harbour carrying a highly explosive load. Roughly 3,000 tons of military munitions, including TNT, picric acid, benzol, and gun cotton, destined for the battlefields in Europe. In a narrow channel, the Mont Blanc accidentally collided with another ship, the Norwegian relief vessel SS Imo. The collision caused a fire on board the Mont Blanc. Knowing the cargo's nature, the crew abandoned ship and shouted warnings, but there was little time. About 20 minutes later, the burning Mont Blanc exploded with a force almost beyond imagining for that era. The blast literally ripped the ship apart and sent a fireball and shockwave tearing through the city. The explosion was so strong, it flattened buildings within a large radius, ultimately destroying or badly damaging around 12,000 buildings. It was one of the largest human-made explosions in history up to that point, often said to be the biggest ever until the atomic bomb. The noise was heard hundreds of kilometers away. A huge plume of smoke rose more than 6 kilometers into the air. The harbor waters were heaved up into a great wave, which crashed into the city's shoreline. This triggered a tsunami about 18 meters, 60 feet high, that swept into the waterfront. In the immediate blast, nearly 2,000 people were killed instantly or within moments, and hundreds more died of injuries. The Halifax explosion was a stark demonstration of how even without nuclear reactions, conventional explosives in large enough quantity can wreak city-shattering damage. Most of the largest explosions in the latter half of the 20th century were not accidents, but deliberate tests of nuclear weapons. It is difficult to imagine a more fearsome explosion without venturing into the nuclear era. And indeed, after World War II, the largest blasts would come not by accident, but by design. These tests produced many startling stories and unexpected outcomes. For example, in 1957, the United States conducted a series of nuclear tests called Operation Plumbob in the Nevada desert. One experiment during that operation, known as Pascal B, inadvertently turned a heavy steel manhole cover into a potential spacecraft. In that test, a nuclear device was positioned at the bottom of a deep vertical shaft and detonated. A thick steel cap had been welded over the top of the shaft. When the bomb went off, the explosion created a furious upward rush of hot gas. That gas shot up the shaft like a bullet through a gun barrel, slamming into the steel cap. The cap, weighing over 900 kilograms, was blasted off the top at an incredible speed. Calculations suggested it might have been propelled upwards at around 200,000 kilometers per hour. That's about 5 times the escape velocity of Earth, the speed needed to break free of Earth's gravity. The steel lid was captured in only one frame of a high-speed camera film as it flew off. It was there in one frame and gone the next. It was never found. Some speculated it was vaporized in the atmosphere from the friction of such rapid travel. Others mused that maybe it flew straight into space. Either way, Pascal B highlighted how unpredictable and powerful even relatively small nuclear blasts could be when confined and channeled. Another test, Castle Bravo in 1954, taught a sobering lesson about nuclear yield. The scientists who designed that thermonuclear device expected a yield of about 5 megatons. Instead, when it was detonated on Bikini Atoll in the Pacific, it delivered a staggering 15 megatons, more than 2.5 times what was predicted. The cause was a previously underestimated reaction involving the fusion fuel. The explosion that resulted was enormous, far larger than any bomb ever used in war. It gouged out a crater around 2 kilometers across in the coral of the atoll and sent radioactive debris high into the atmosphere. Fallout from Castle Bravo drifted over an area of more than 18,000 square kilometers, over 7,000 square miles, contaminating inhabited atolls downwind and even sickening the crew of a Japanese fishing boat that had the misfortune of being too near. Castle Bravo became a byword for the dangers of nuclear testing and the unpredictable nature of these weapons. The incident spread panic and outrage, and it underscored how little margin for error there was with these monstrous devices. And then there are the mysteries. In 1979, a U.S. surveillance satellite called Vela picked up a distinctive double flash of light over a remote part of the South Atlantic, the kind of signal one would expect from a nuclear detonation. It was nighttime in that region between South Africa and Antarctica, and no nation announced a test or accident. To this day, the event, often called the Vela incident, remains unexplained. Some suspect it was a secret nuclear test, possibly conducted jointly by 2 countries in secret. Others suggest it might have been a meteoroid impact or a technical glitch, some non-nuclear phenomenon. But no debris or fallout was ever conclusively detected from it, leaving a lingering question mark. So in the annals of nuclear history, there remain mysteries, enigmas, hinting that there may have been clandestine flashes in the night that we will never fully know. These examples from the nuclear testing era show both the extent of human-engineered explosions and the limits of our knowledge at times. But as incredible as these man-made blasts have been, nature still surpasses them by orders of magnitude. To truly appreciate the contrast, we must now turn our gaze to the natural world and even beyond Earth, where explosions dwarf anything humanity could ever create. Volcanoes, for instance, can outdo nuclear weapons by far. The eruption of Mount Tambora in 1815 is a prime example. Tambora, in Indonesia, exploded with such force that it ejected an estimated 160 cubic kilometers of material and released energy on the order of 800 million tons of TNT, roughly 800 megatons. That's about 14 times the yield of the Tsar Bomba. The sound of the explosion was heard nearly 2,600 kilometers, over 1,600 miles away, and the ash thrown into the atmosphere dimmed the sun worldwide. The following year, 1816, became known as the Year Without a Summer because global temperatures dropped, causing crop failures and famine in far-flung regions. Scientists rate volcanic eruptions on the Volcanic Explosivity Index. Tambora was a VEI 7, one of the most powerful in recorded history. By comparison, the massive eruption of Hunga Tonga Hunga Ha'apai in 2022 generated the most powerful pressure wave ever measured in Earth's atmosphere, was ranked a VEI 5. There have been even larger eruptions in the ancient past. The Toba supereruption about 74,000 years ago was a VEI 8, an almost unfathomable event. It may have released energy equivalent to billions of tons of TNT. Toba covered much of Asia with ash and likely caused a severe global volcanic winter. Some researchers think it nearly drove early humans to extinction, leaving only a small population to repopulate the world. These natural events make even our biggest bombs look tiny. Nature's power, whether through an angry volcano or a hurtling asteroid, dwarfs our own. They remind us that Earth itself can unleash forces far beyond anything we can create. And if we step beyond Earth, the scale of explosions grows even more mind-boggling. Over 30 years ago, scientists detected one of the brightest stellar explosions in 400 years. In 1987, astronomers observed a supernova in a nearby galaxy, the Large Magellanic Cloud, about 168,000 light-years away. This supernova, named SN 1987A, was the brightest and closest stellar explosion seen in centuries. A star about 20 times more massive than our Sun exhausted its fuel. It could no longer withstand its own gravitational weight, so it catastrophically collapsed and then blew itself apart. When such a massive star can no longer sustain its own weight, it implodes and then explodes in a titanic blast, forging new elements in the process. In fact, the iron in your blood and the calcium in your bones were created in long-ago supernova explosions. For a brief period, SN 1987A shone with the power of hundreds of millions of suns. It was so bright that, if you were in the southern hemisphere at the time, you could actually see this explosion with the naked eye as a new star in the sky. It remained visible for several months. All the nuclear bombs ever built wouldn't come close to a fraction of that energy. To give an analogy, a hand grenade is to an atomic bomb as an atomic bomb is to a supernova. The energy released was on the order of 44 joules. That's a 1 followed by 44 zeros, an almost incomprehensible number. The aftermath of that supernova left a dense core and a glowing ring of gas encircling the blast site that had been there long before the explosion. That ring, about a light-year across, had existed for at least 20,000 years before the star blew. The flash of ultraviolet light from the supernova energized that gas and made it glow for decades afterwards. This cosmic blast was a spectacular event for science, and yet, in the grand scheme of the universe, even supernovae are not the largest explosions known. The universe had bigger fireworks in store. The title for the most powerful types of explosions observed in the universe goes to gamma-ray bursts. These are extraordinary cosmic events believed to occur when extremely massive stars collapse into black holes or when neutron stars merge, events that release unimaginable bursts of energy in narrow beams. In October 2022, instruments detected one of the brightest gamma-ray bursts ever recorded, nicknamed the BOAT, brightest of all time. It originated billions of light-years away, yet it was so energetic that detectors on satellites and even the Voyager 1 probe at the edge of our solar system picked up its signal. In terms of sheer brilliance, imagine compressing the light of an entire galaxy into a brief moment that gives a sense of a gamma-ray burst's power. For a few seconds, this burst likely outshone all the stars in its galaxy. Scientists estimated it was as bright as 1,000,000 trillion suns. The burst, known formally as GRB 221009A, carried photons, packets of light, with energies tens of millions of times higher than the light we see with our eyes. It was an absolutely extreme event, the kind that might occur only once in many thousands of years. If a burst like that happened much closer to us and its beam hit the Earth, the effects could be dire. It's thought that a gamma-ray burst pointed at Earth could strip away much of our ozone layer and bathe the world in harmful radiation, potentially causing a mass extinction. Indeed, some researchers have hypothesized that a gamma-ray burst might have been responsible for a past extinction event on Earth about 440 million years ago. Thankfully, such bursts are incredibly rare, and the chances of one happening close enough to harm us in the near future are very low. Scientists estimate that a burst as powerful and close as the 2022 event might occur only once in several million years. In cosmic terms, that is exceedingly rare, a tiny chance in a vast expanse of time. Yet even gamma-ray bursts may have met their match in a newly observed cosmic explosion announced in 2023. Astronomers reported an event called AT2021LWX, believed to be the most colossal cosmic explosion ever reliably observed. Unlike a typical supernova that shines for a few weeks, this event has been going strong for over 3 years, and it's still going. It was first detected in 2020, and by 2023 was still radiating an immense amount of energy. At its peak, AT2021LWX is about 2 trillion times more luminous than the Sunday Yes, trillion with a T. That makes it roughly 10 times brighter than the brightest supernova previously known. The scale of this explosion is almost beyond comprehension. It's thought that what we're seeing is a supermassive black hole in a distant galaxy that encountered an enormous cloud of gas, possibly thousands of times the mass of our Sun, and is in the process of tearing it apart and devouring it. As the black hole rips through the gas cloud, the debris heats up and shines incredibly brightly. The whole system has formed a structure maybe 100 times larger than our entire solar system, glowing as this cosmic cataclysm unfolds. This explosion is so large and long-lasting that we don't even have a comparison for it in human experience. We are only witnessing the faint echo of it eons after it began. Interestingly, because it's so far away, this event actually occurred roughly 8 billion years in the past, when the universe was younger, and its light has been traveling all that time to reach us now. If something like AT2021LWX were happening in our cosmic backyard, say, at the edge of our solar system, it could probably wipe out all life here and even dismantle the very structure of the solar system. Thankfully, it's happening at a very safe distance of about 8 billion light-years away. Events like this remind us that no matter how powerful our weapons, the universe always has something far more powerful. It's almost comforting, in a way, to recognize that we are not the biggest bullies on the block, that there are forces out there so immense that our quarrels seem small by comparison. It makes one wonder, will humans ever create something as powerful as a supernova or gamma-ray burst? Or are such titanic energies forever beyond our reach, confined to the cosmos? Perhaps it's best if they remain so, for our own sake. After all, the most colossal explosion of all was the one that gave birth to the universe itself, the Big Bang. Compared to that, even a gamma-ray burst is a flicker. These cosmic scales put our human powers in perspective. We have journeyed through scenes of unimaginable destruction and extraordinary power, and in doing so, we have touched something both terrifying and strangely clarifying. We began with a single bomb falling over Hiroshima, a moment in human history that proved how quickly the ordinary can become unspeakable. One instant there is morning light, the quiet rhythm of a city beginning its day, people stepping outside, water boiling, doors opening, laughter and small plans for later. The next instant, the air itself becomes fire, and the world is rewritten in heat and pressure. We watch the blast tear through streets and homes, not as an abstract event, but as a rupture in countless individual lives, each one filled with details that mattered. We saw how survivors bore what no one should ever have to bear, bodies and minds pushed beyond the limits of endurance, and yet still moving forward, still breathing, still searching for loved ones through smoke and ash. We remembered the shadows left behind, not as a metaphor, but as a physical imprint, a silent testimony pressed onto scorched stone and concrete. Those shapes are not just marks, they are questions. They ask what humans are capable of, what we justify when we are afraid, and what we forget when time passes and the headlines fade. We moved through time after that, watching the knowledge of nuclear fire spread into the world like a stain that would not wash out. We witnessed how that terrible understanding influenced the buildup of arsenals, machines, and systems designed not only to win wars, but to end them by ending everything. We considered how deterrence became a kind of cold logic, a promise that safety could be maintained by the threat of annihilation, and how that logic demanded constant readiness, constant fear, constant calculation. Yet even as nations piled up weapons, we also saw another impulse rise alongside it, the impulse to prevent the very fate those weapons implied. We saw people pushing for treaties, for restraints, for communication, for safeguards, for the hard work of diplomacy and verification, for the slow building of trust in a world that often rewards suspicion. We imagined the worst-case scenarios of nuclear war, not to sensationalize them, but to remember why such weapons must never be used. Cities emptied in minutes, hospitals overwhelmed before they even understand what is happening, firestorms consuming neighborhoods, radiation lingering long after the flames are gone, generations living with consequences they never chose. Step by step, you and I traveled from the smallest scale of personal tragedy, a single family, a single street, a single child searching for a parent, to the grand scale of systems and strategies that can decide the fate of millions. And then we widened the lens even further, beyond human hands, beyond politics, beyond plans. We explored how even the largest bombs we have built are dwarfed by the forces of nature. Volcanoes can throw dust into the sky and cool the planet for years, turning summer into a dim season of failed harvests and hunger. Asteroids can arrive without warning and reset the course of life, raising walls of water, darkening skies, collapsing ecosystems, leaving only the stubborn survivors to begin again. Exploding stars can outshine galaxies, releasing energies that make our most powerful weapons seem like brief sparks. And there are mysterious bursts of energy from deep space, sudden flashes that remind us how much we do not yet understand, how the universe can speak in a language of extremes. It is incredible to think of the range of destruction and power we have considered, from a single building reduced to ashes, to continents reshaped by catastrophe, to entire galaxies lit up by stellar blasts, each scale changing the meaning of the word enormous. Our journey began in Hiroshima's devastated streets and ended in the farthest reaches of the cosmos. And that arc carries a stark lesson. It reminds us of the destructive capacity of humanity, and also of the overwhelming power of nature. Power that does not hate, does not intend, does not judge, but simply is. We have seen how one morning in 1945 changed thousands of lives in an instant, and how the echo of that instant has stretched across decades. The threat of nuclear destruction still haunts us, sometimes loud, sometimes quiet, sometimes disguised as routine, but always present in the background of modern life. Even when we do not speak about it, the existence of such weapons shapes decisions, alliances, fears, and the way nations posture and prepare. And yet, as we looked outward into the grand theatre of the universe, we also saw something humbling. Even our worst weapons are small sparks against the backdrop of stars, tiny flashes compared to the long, patient forces that shape planets and the vast, indifferent energies that cross space. This perspective does not excuse what humans have done, and it does not make human suffering smaller in any moral sense. A single life still matters completely to the one living it. A single family's loss is still an entire universe of grief to those left behind. But the cosmic perspective does something else. It strips away the illusion of importance that sometimes tempts us to violence. It reminds us that our time is brief, our world is delicate, and our choices ripple outward through a web of lives that cannot be replaced. It urges us to see peace not as a passive state, but as an active responsibility, something that must be protected by wisdom, patience, and empathy. When you consider how rare it is for life to exist at all, how many conditions must align for a planet to be habitable, for water to flow, for organisms to persist, for minds to emerge that can ask questions and tell stories, it becomes hard to justify anything that casually risks turning all of that to dust. In that sense, the lesson is both simple and enormous. Life is precious. It is fragile. It is not guaranteed. And because it is not guaranteed, it deserves care. As you lay here now, safe and quiet, you can let these thoughts drift through your mind like distant clouds that pass without needing to be chased. You do not have to solve history tonight. You do not have to carry the full weight of everything that has happened. The world outside is calm at this moment, at least in the space around you. The room is still, the air is steady. The tragedies of the past are not here with us now, except as memories and lessons. And there is a difference between remembering and reliving. Remembering can be gentle. Remembering can be respectful. Remembering can be a way of honoring without reopening every wound. Take comfort in the fact that you are okay, right here and right now. Your body is supported, your breathing continues without effort, your heartbeat keeps its quiet promise. By learning about these events, from the shadows left on concrete in Hiroshima to the brilliant glow of a supernova in a distant galaxy, we honor the experiences of those who suffered and deepen our appreciation for the peace we have today. We also strengthen something inside ourselves, a kind of moral compass that points away from cruelty and toward care. Knowledge can be heavy, yes, but it can also be a lantern. It can illuminate the consequences of choices so we are less likely to repeat them. It can teach us that fear does not have to become hatred, that power does not have to become domination, that strength can also mean restraint. With that understanding, you can gently close your eyes and let the enormity of what you have heard settle softly, not like a stone, but like a blanket being placed carefully over your shoulders. The universe is vast, and that vastness can feel cold if you stare at it the wrong way. But it can also feel protective, like a great silence that makes room for your small, warm life. In this vast universe of ours, may we always strive to cherish life and avoid the flames of destruction. Remember that even in darkness, the light of understanding and empathy can guide us, not as a dramatic rescue, but as a steady direction, one quiet decision at a time. Allow yourself to appreciate this quiet safety. There is something profound about a simple moment in which nothing is demanding your immediate survival. Take a deep breath in, slow and easy, and as you exhale, imagine the darkness of the room gently embracing you, not as emptiness, but as rest. Each breath out carries away any remaining tension or worry, and if your mind tries to return to the images, you can let it, briefly, and then let it drift onward again. You have made a long journey in your mind tonight. You traveled across history and across space, across fire and ash, across shockwaves and starlight. You considered what humans can do to one another and what nature can do without meaning to. You touched the edges of horror and also the edges of awe, the kind of awe that makes you feel small but also strangely connected to everything. Now you have arrived at a place of rest. The bed beneath you is soft, the muscles of your face can loosen, your shoulders can drop, your hands can unclench. The world outside is at rest, and even if it is not perfectly at rest everywhere, it is not demanding you right now. Nothing is threatening you here. Your mind can set down its heavy bundles for the night. You can let all these heavy thoughts float away now, knowing you are safe. Imagine them like dandelion seeds carried on a gentle breeze, rising, separating, becoming lighter as they drift farther from you. You do not need to hold them tightly to respect them. You do not need to keep them sharp to keep them true. You can honor the past and still allow yourself peace. In this moment, there is no chaos, no explosions, only quiet and safety. You have permission to let go. You have permission to rest. You have permission to be simply a person in a bed, breathing in the dark, letting the day end. You are safe. The night is peaceful. The story of what happened, both terrible and awe-inspiring, can now become a quiet whisper as you drift towards sleep. Let that whisper soften further, becoming less like words and more like a distant ocean, present but not demanding. Sleep now, knowing you are cherished, safe, and at peace. If your thoughts flicker, let them flicker. If they fade, let them fade. Your body already knows what to do. It knows how to sink into the mattress, how to slow the breath, how to loosen the grip of wakefulness. Slowly, peacefully, you drift into a deep and restful sleep. Sleep now, allowing yourself to rest in the gentle stillness, and let tomorrow arrive only when it is ready.